So the pacemaker cells, they're autorhythmic. They're the ones that are going to help our heart, allow our heart to spontaneously beat and allow the heart to contract without any external input. There is external input that we'll get to that regulates this, but you don't need it for the heart just to keep beating. And there's special receptors, gated channels in the heart that allow this to happen. Very, very cool. So the first thing to start with, right, is I usually start with when I draw these action potentials is some of these values over here. I'm going to start with minus 60 over here. So we are going to be a little bit less negative, go up to 20 and then 0 somewhere like here. So we are starting a little bit higher. So you may ask, what is the resting memory potential, right? Because that's sometimes where we start here. There is none. Instead of a resting memory potential, there is a pacemaker potential, it's called. And there's no rest. These cells don't rest. There is, we're going to start at minus 60, but we're going to go up. Then we're going to go up some more. Then we're going to go back down. We'll go down. We're going to go up. We're going to go up some more. Okay, let's do some labeling. First, I told you there's no resting. So what, I have to be able to draw something, all right? This is called a pacemaker potential. The pacemaker potential is somewhere in between minus 60 to about minus 40. Around here, again, not the best scale there, it's probably more like 30, is where this pacemaker potential, which means this slow incline until we reach threshold. Right? We still have to be able to reach threshold, and we do have to have gated ion channels, sorry, voltage gated. And now they're actually calcium in this case. Why can they be calcium instead? Because calcium's still going to rush in. There's still a gradient for it. So to get from here to here, this is threshold. Here is, so I'm sorry, this arrow should be like right here, right? If that's where it's happening. Step 2. Step 1 is, I haven't told you really what this is. This is due to something called funny channels. I is a current, so this is actually our funny current. And it's due to the opening of funny channels. They're funny because they're funny. They allow sodium and calcium in. You know they have to be letting a positive ion in because we're depolarizing, or it could be a negative ion out, but it's not. We know if we're going this way, there's some movement of ions, right? So first, just telling you what those are. Calcium channels open, should be no surprise. That's going to cause this rapid depolarization. Up here, just like typically, we're going to have repolarization initiated due to potassium channels opening. Potassium flows out, right? None of that should be too new. As soon as we hit down here again, we're going to activate these funny channels again. So these funny channels are hyperpolarization activated. Actually, activated, opened, we'll say opened by this hyperpolarization. Opened by the membrane potential being around minus 60. So as soon as the membrane potential hits minus 60, right here, these channels are going to open. And that immediately causes the flow of ions in until you reach threshold again. Up, sodium, potassium channels open, back down. Let's do one more here. So we are repolarizing the cell due to potassium influx. Repolarizing. Oh, we hit minus 60. Sodium, funny channels open and open and open enough that we reach threshold, boom, up. Super cool. So it's spontaneous over and over again. A constant cycle. Really pretty cool. Okay, is there anything else I want to tell you here? I don't think so. Let's do a learning check. Label each of the following with contractile cardiac cells, pacemaker, or skeletal, and then what ion is responsible for both depolarization and repolarization.